Okay, looks like we're going to try some Common Core Geometry, Module 1, looking at Lesson 30, Example 3, which is on page 241 of the teacher guide. It says in the figure, we got triangle ABC reflected over AB, so to form triangle ABD. So let's go ahead and start a triangle. So I'm going to grab the point tool. I'm going to put out a couple points. It looks like A is sort of at the top, B maybe somewhere over here, C over here on the left somewhere. So I'm just going to go ahead and hit my select tool, select everything, construct segments, sort of create that triangle in a bit of a hurry. And I'll click on the labeling tool. I'll go ahead and label these points A, B here in the middle, and C. Maybe I'll pull B down a little bit so it's a little bit out of the way. All right, and then it says reflect this triangle over segment AB. So I'm going to click on my selection tool. I'll click off so no lines are selected. I'm just going to go ahead and double click on segment AB, so that'll be my reflection, line of reflection. I'm going to go ahead and reflect, these things all don't reflect, they're on the line, so I'll click the segment AC, I'll select segment CB and point C, and I'll go to the transform menu. I'll go ahead and do that reflection. And I'll also turn on the label of the, you can see where it created over here, that looks like point D over on the side here, so I'm going to click on that. That's the reflection. Sketchpad wants to name it C prime, but I can just relabel it as D, as it says in the information here. All right, and then it's saying points P, E, and F are midpoints of AB, BD, and BC, respectively. So I'm going to do them actually all at once to save a little time. So we need segments AB, so I'm going to select that segment. I need BD, select that segment as well, and BC. And I should be able to construct midpoints. If I go to the construct menu and it does those three. Could have just done them one at a time, but I figured that saves some time. Now I'm just going to label them properly. So it says E is the midpoint of BD. So I'm just going to click on that because I know it's going to use D. All right. I guess I'll just have to relabel all of them. So that's point E. This is going to be point P, according to the information, and this should be point F. All right, yes, F is the midpoint of BC, correct. And then it says for AH is equal to AG, so it looks like I have to draw in some additional lines. So there is a segment connecting C and P and D. So let's get our segment tool. Let's just go ahead and construct a couple of these segments. P and D also is there. And also A and F is a segment, as is A and E. And then they also have a couple points in here, H and G. So let's go ahead and get the point tool. I'll put those points right on those lines of intersection. I get them to highlight. And so I know where to put those points. It looks like G is on the right, so I will go with that one first. Move that over here, and H. All right. So if AH equals AG, so that's a little information there. I'm going to use this marking tool. So AH and AG are the same. So I'm just going to click on the marking tool, move it over, and notice that kind of changes shape a little bit when I'm about ready to mark. I'm just going to click once to get that tick mark. I'll click over here too, so I know that AH and AG are equal. It wants me to prove PH is equal to GP, so that's these two little segments are equal to each other. All right, so it looks like we can go ahead and do that proof. Give my stuff a little space. I'm going to actually pick up the whole figure and move it all over to the left a little bit. And I'm just going to do the proof. We'll write our proof out over here in that empty space. So I'm going to click on the text tool, and I can just go ahead and draw a pretty big box over here so that we can go ahead and actually start our proof. So I'll write in proof. I could do some things with the font and sizes, but we're not going to worry about that. So first thing I think we're going to look at is, say, this segment here, this entire segment, AF. That is the same as segment AE due to the reflection over that line. So let's go ahead and write that down as a statement. So since it's just length measurement, we can say AF is equal to AE. And we can say that the segments are preserved rigid motion due to that reflection. All right, and then we also have angle FAB and angle EAB, because they're kind of formed from that same reflection. So I actually want to turn on the marker tool. So we'll do that, and I'll actually get the marker tool to change shape. I'll click and hold from one side of the angle to the other. And it kind of writes that little angle marker in. I'll do the same thing on the other side. Click and hold, drag over, so I can kind of see that those angles are the same, and it'll probably help me out and as I work on the proof. So let's get back over to here. So I'm going to say the measure, and I'm going to use some tools. They have lots of drawing tools here. I'm going to use the angle tool, angle indicator. So that's FAB equals the measure of angle EAB. And that is also, this is, and I'll just use the shortcut angles, preserved rigid motion. So you can see this. I'll move the box down a little bit too, because there's no need to hide it underneath there. All right, so you can kind of see how that's coming out. All right, I also know that these two segments are equal, AH and AG. So why don't I just write that down? AH is equal to AG. That was given. I also know that segment AP is equal to itself due to the reflexive property. So I'll just say AP is equal to AP. That's reflexive. And now it looks like I have this side, this angle up top, and this side. So it looks like I have this little triangle in the middle. Why don't I try and highlight it a little bit? Why don't I just use this polygon selection tool here, and I'll just actually kind of draw it out so it'll kind of stand out a little better. So I have this triangle, oops, I just have to go back here, and this triangle. So those are the ones that look like I can show that they're congruent. So let's go ahead and put that down. So I have triangle, and that symbol is hidden in this little drop-down menu. So triangle APH, congruent, which is right here, to triangle hidden in this drop-down. There's a whole bunch of other symbols over here. Triangle APG, and that is because I have a side, angle, and side. All right, and then really we can just go ahead and say these last two parts, this PH and GP. So I'll just turn on the tick marks one more time to make it a little clearer. So I'm just going to double click this time. I'll get that, oops, I click enough times until I get it right. All right, and I'll just go ahead and fill in this last step. Maybe we'll make it look a little nicer. And I get that PH is equal to GP. We have that from corresponding sides. We'll use some symbols to save some space. Congruent triangles are, and let's just say equal. All right, so I can close out this text window. I don't need that anymore. And like I said, maybe we could just make these look a little nicer. Spread them out a little bit. Guess that's about the best I could do. All right, and there you have it. There's the proof on page 241. We'll do another one soon.